let us do a very important concept, and the concept is congruent figures. Let's understand this. For this, I'm going to give you an example. I'm going to consider two dolls. Observe these two dolls. Look at these two dolls. They are of the same shape, isn't it? Yes. They are also of the same size. So they are called as congruent figures. That means one thing we know, what are congruent figures? Figures having the same shape and the same size are said to be congruent figures. Let's consider a few more examples to get a grip on the concept. Let's consider two coins. Look at these two coins. They are of the same shape and they are obviously of the same size because it's the same 1 rupee coin. If you pick up one and place it above the other, they'll exactly fit into each other, right? Let's take a very simple example which we can easily reconfirm. That is, consider your two palms. Now, if I consider my two palms and I place it one above the other, do they exactly fit into each other? Yes. That means I can say that both my palms, they are congruent because they are of the same shape and they are of the same size. Isn't that easy? So that means we have understood what are congruent figures. Now let's understand what do you mean by similar figures. Let's consider the same example. We have a doll. I'm going to consider a few more dolls. Listen, I consider another doll which is smaller than this. I consider another one which is even more smaller than this. That means right now I've got three dolls here. Three beautiful, pretty dolls here, right? Look at all these three dolls. They are of the same shape. Check. Yes. All. But are they of the same size? No. Such figures, they are not congruent, but they are similar figures. So what do you mean by similar figures? Having the same shape, but not necessarily of the same size. That is what you mean by similar figures. So it's very simple. What are similar figures? Figures having the same shape, but not necessarily the same size are said to be similar figures. Let's understand a few more examples. If you look at the photograph here, you see a pretty girl here, there are different photographs of her, right? But they are of the same shape, but are they of the same size? No. Now when you go to take a passport size photograph, you get different photographs. The same photograph in different sizes. They are similar. They are of the same shape, but not of the same size, right? Let's take one more example. If you look at the earth, the actual earth and the globe, they are of the same shape but not of the same size. They are similar figures. So we are very clear about the concept now. What do you mean by congruent figures? They are of the same shape but also of the same size, right? They are said to be congruent figures. Now, when we show the symbol of congruency, you know what? Understand this. Same shape is determined by the curve there. You see that? That curve determines the same shape. And same size is determined by the equality symbol there. That is why in congruency you have that equality and the curve above. That shows it is of the same shape and the same size. So now we are talking about similar figures which are of the same shape but not of the same size. That means in this case, will we have the equality? No, we'll only show the curve, and that is what is represented by the concept. That is the symbol for similarity. So isn't that clear? Very, very, very important concept, right? So that is the symbol for similarity. Isn't that easy? Beautiful, right? Now, in this chapter, we are not going to learn about similarity of dolls, similarity of earth and globe. No. Our study is going to be restricted to similarity of triangles. So let's consider, I've got a phone here, I've got a triangle there. There's a triangle there which you can see ABC, and we have the length of the sides given of the triangle. It's a right angle triangle. What I want to do is, I want to enlarge this triangle. I want to make it double. Now on the screen you can double it, right? You can just zoom in, zoom out, right? Zoom. Yes, let's do that. So I'm going to do that. And now I zoom in and I want it to be doubled. So I'm taking it twice. So when I zoom in, I get like this, right? I get a bigger triangle. It's the same triangle. They are of the same shape. It's a right angle triangle. There also it's a right angle triangle, right? They are of the same shape but not of the same size. It's exactly double, right? That means these two triangles which I see here, after doubling, what I'm doing is I'm just changing the name of the vertices. So I take it as PRQ instead of ABC. So now when you distinguish between this, otherwise I'm not able to distinguish it. Now I can distinguish. One is triangle ABC, the other one is triangle PRQ. Now what we can see about this two triangles is triangle ABC and triangle PRQ. We can say that they are similar, of the same shape but not of the same size. Let's put the symbol of similarity in between them. That means I can write that these two triangles ABC and PRQ, they are similar. That's what I've written. Now let's understand. We know when two triangles happen to be congruent, we know that the corresponding sides are congruent, the corresponding angles are congruent. What happens when two triangles are similar to their sides and to their angles? Let's understand. Let's talk about sides first. Now we know that these two triangles are similar. So what happens to their corresponding sides? Now in triangle ABC, we have AB as 8.5, we have BC as 5 centimeter, and we have AC as 10 centimeter, right? Let's observe now what happens to the triangle sides of the triangle in PRQ, right? Observe here we have this all the sides of this triangle given. So now I want to know, we have doubled and got PRQ, right? So if AB is 8.5 centimeter, its double would be 17 centimeter. But which side is 17 centimeter? PR, QR or PQ? Which one? Yes, you're very correct. It has to be PR. It's the corresponding side. It's the matching side, right? Beautiful. And that's the word which you use, corresponding side. Right now we know BC here is 5 centimeter. So which side is going to be 10 centimeter? The double. Which one? PQ or QR? Yes, you're very correct. The corresponding side, that is QR. And now we know that AC here is 10 centimeter. So obviously its corresponding side PQ is going to be 20 centimeter. Now because we doubled it, we got this way, right? Now let's look at the incongruency. It is about the corresponding sides are equal. Corresponding sides are congruent. What happens here? Yeah, they're not congruent. They are not equal. Let's take the ratio. Now the ratio of the corresponding sides will take. So for AB, its corresponding side is PR. So let's take that ratio. So it is 8.5 upon 17. Right? 8.5 upon 17 is nothing but 1 upon 2. So we get the ratio is 1 upon 2. Next, we take BC and its corresponding side is QR. So we take BC upon QR, which is nothing but 5 upon 10. That is 1 upon 2 again. Next, we take AC upon PQ, which is nothing but 10 upon 20. So we take, and that ratio is 1 upon 2. So what do we observe? What do we observe about the ratios of the corresponding sides here? Look, the ratios are 1 upon 2, 1 upon 2, 1 upon 2. That means we are saying that all the three ratios, that is AB upon PR, is equal to BC upon QR, is equal to AC upon PQ. That means all the three ratios are equal. That means what are we saying about the corresponding sides? We are saying that the corresponding sides, their ratios are equal. When ratios are equal, the other word for that in mathematics is proportion. That means we can say that corresponding sides are in proportion. That means we know one thing now, when two triangles are similar, their corresponding sides are in proportion. That means the ratio of the corresponding sides are equal. Right? Isn't that easy? This is very important. Understand. So that's what we learned about the sides. Now let's discuss about angles. Now, triangle ABC, that was doubled and we got the triangle PRQ. So that means angle A, which was 30 degree, now it will be doubled, right? And angle P will become 60 degree, no? Because we have doubled it. No, because if we double it and the angles are not going to be doubled. Why? Because here the shapes remain intact. Shapes are the same. Now remember, shape is determined by the measurement of the angle. If angles remain same, then only the shape will remain same. That means one thing we have understood, that since the shape remains the same, angles would remain the same. It will not be doubled like the sides. This is very important, right? So that means here, we know that angle A is 30 degree. That means angle P will be 30 degree. Angle B is 90 degree. So angle R will be 90 degree. Angle C is 60 degree. That means we have angle Q as 60 degree. That means we are saying that angle A is congruent to angle P, angle B is congruent to angle R, and angle C is congruent to angle Q. So what did we learn about the corresponding angles? We learned that the corresponding angles are congruent. So one thing we learned, that when two triangles are similar, their corresponding sides are in proportion. That means their ratios are equal, right? And we learned about the angles, that corresponding angles are congruent. Now remember, if triangles are similar, this is happening. That means the vice versa is also true. That means I'm saying that if all the three ratios of the corresponding sides and all the three pairs of corresponding angles are congruent, then the triangles are similar. Isn't this? That's the concept which you have learned, which is very, very important.